Imagine a world untouched by sunlight, a place where life has evolved in complete darkness for millions of years. This is Movile Cave, a hidden realm located in southeastern Romania. Discovered in 1986, this cave has captivated scientists and explorers alike with its unique and isolated ecosystem. The discovery of Movile Cave was purely accidental. Workers from a Romanian power plant were surveying potential sites for construction when they stumbled upon a sinkhole. Little did they know that this unassuming hole in the ground would lead to a scientific treasure trove. Upon descending into the sinkhole, they found themselves in a labyrinthine network of passages and chambers, culminating in a large air-filled cave. The air within the cave was thick with humidity and had a pungent sulfurous odor. This was the first indication that Movile Cave was no ordinary cave. It was a place where the normal rules of life seemed not to apply. The discovery of this hidden world sent ripples of excitement through the scientific community, as it promised to reveal secrets about life in the most extreme environments on Earth. Movile Cave presents a hostile environment that would be deadly to most life forms. The air is extremely low in oxygen, with levels hovering around 7 to 10% compared to the 21% found in the atmosphere above. This alone would make it difficult for humans to breathe, but the dangers don't end there. Carbon dioxide, a waste product of respiration, is found in high concentrations within the cave, reaching levels 100 times higher than the outside air. Adding to this toxic cocktail is the presence of hydrogen sulfide, a gas that is not only poisonous but also gives the cave its characteristic rotten egg smell. These harsh conditions make Movile Cave a challenging environment for life to exist, let alone thrive. The darkness within the cave is absolute, as no sunlight has ever penetrated its depths. This means that photosynthesis, the process by which plants and other organisms convert sunlight into energy, is impossible within this subterranean realm. The air is also saturated with humidity, creating a perpetually damp and humid environment. Despite these extreme conditions, life has found a way to flourish in Movile Cave, demonstrating the remarkable adaptability of life on Earth. Despite the hostile environment, Movile Cave is teeming with life, albeit a very unique kind of life. Over 50 species of invertebrates have been discovered within the cave, many of which are found nowhere else on Earth. These creatures have adapted to survive in this unique ecosystem, relying on chemosynthesis rather than photosynthesis for their energy. Among the cave's most fascinating inhabitants are the blind spiders, scorpions, and centipedes. With no need for sight in the pitch-black environment, these creatures have evolved to have either reduced or completely absent eyes. Instead, they rely on their highly developed senses of touch and smell to navigate their surroundings and hunt for prey. Worms, leeches, and isopods also crawl through the cave's damp passages. These creatures play an important role in the cave's ecosystem, breaking down organic matter and recycling nutrients. Microbial life, including bacteria and fungi, thrives in the cave's nutrient-rich waters, forming the base of the food chain. These microbes have evolved unique metabolic pathways that allow them to survive in the absence of sunlight. A chemosynthetic symphony: how life thrives without sunlight in Movile Cave. The key to survival in Movile Cave lies in chemosynthesis, a process by which organisms derive energy from inorganic chemicals rather than sunlight. In the absence of sunlight, bacteria form the foundation of this unique ecosystem. They harness energy from the oxidation of hydrogen sulfide and other sulfur compounds that seep into the cave from deep within the earth. These chemosynthetic bacteria form microbial mats on the cave walls and in the water, providing a food source for other organisms higher up the food chain. Grazing invertebrates, such as snails and isopods, feed on these microbial mats, while predators like spiders and centipedes hunt the grazers. This intricate web of life, fueled by chemosynthesis, creates a self-sustaining ecosystem that has thrived in isolation for millions of years. The organisms within Movile Cave have evolved unique adaptations to survive in this extreme environment. Many have lost their pigmentation, becoming pale and translucent. Others have developed elongated appendages and enhanced sensory organs to navigate the darkness and detect prey. The study of these adaptations provides valuable insights into the limits of life on Earth and the mechanisms by which organisms adapt to extreme conditions. A glimpse into the past and future, the scientific significance of Movile Cave. Movile Cave offers a unique window into the past, providing clues about what life might have been like on early Earth before the evolution of photosynthesis. The cave's isolated ecosystem is thought to have been sealed off from the outside world for at least 5.5 million years, creating a time capsule of evolutionary history. By studying the cave's inhabitants, scientists can gain insights into the early evolution of life on Earth and the development of chemosynthetic ecosystems. The cave also provides a natural laboratory for studying the effects of long-term isolation on evolution. The unique adaptations of Movile Cave's inhabitants demonstrate the power of natural selection to shape life in response to environmental pressures. Furthermore, Movile Cave has implications for astrobiology, the study of life beyond Earth. The cave's extreme environment and the presence of chemosynthetic life provide a model for what life might look like on other planets and moons in our solar system and beyond. Places like Mars or Jupiter's moon Europa, which lack sunlight but may harbor underground water sources, could potentially support similar chemosynthetic ecosystems. Astrobiological implications: Movile Cave and the search for life beyond Earth. Movile Cave's unique ecosystem thriving without sunlight has sparked immense interest among astrobiologists. The cave's chemosynthesis mirrors environments thought to exist on other celestial bodies. These bodies, with icy surfaces or subterranean oceans, might support similar life forms. Europa, one of Jupiter's moons, may have a subsurface ocean beneath its icy shell. This ocean, heated by Jupiter, could contain hydrothermal vents like Earth's. These vents release chemicals that could support chemosynthetic bacteria. Movile Cave serves as a valuable analog for these environments. Studying the cave's inhabitants offers insights into potential extraterrestrial life. Protecting a fragile ecosystem restricted access to Movile Cave. Recognizing the scientific significance and fragility of Movile Cave's ecosystem, access to the cave is strictly limited. Only a handful of scientists are granted permission to enter the cave each year, and they must adhere to strict protocols to minimize contamination. These protocols include wearing sterile suits, gloves, and masks to prevent contamination. The limited access ensures the cave's unique ecosystem remains undisturbed for future study. Movile Cave stands as a testament to the resilience of life and the wonders waiting to be uncovered.